Hello, friends. I think we're supposed to be 4 people, but we're currently 3 people. So in the middle of the panel, it's going to be interrupted by someone rushing to the front and sitting down and joining the conversation.
We could also view it as my alt actually is my alt.
The proof it's finally being revealed. So this is the panel on MEV on modular. I think we're going to try and split this up very plainly into 3 sections or questions that the panelists are going to kind of hopefully run wild with. And they're related to sort of security on modular, then incentives, and finally winners and losers in the preventative game of MEV. So before we get started, maybe we could do some brief. I mean, the reason I'm excited to sort of host this panel is because actually all 3 of you wrote the paper on cross-chain MEV, right?
I think not Guillermo.
Not Guillermo.
Two out of 3.
Two out of 3.
So the people who literally are writing the book are sort of present so we can get their perspective, but maybe they have more profound sort of personal details that are relevant that they want to introduce themselves very briefly.
Yeah, I'm Tarun, founder of Gauntlet, but also have written a lot of papers on both MEV and AMM.
Yeah.
Hello?
It works?
Yeah.
Oh, I'm Alex, researcher at Flashbots. Wrote a paper with Tarun as a co-author on cross-domain MEV and did some research on MEV on different fronts. Yeah. Before cross-domain MEV, I was looking at proof of stake and MEV on proof of stake chains, on Ethereum in particular.
Cool. Well, so what we wanted to do to start the panel, even though we're kind of midway through the day, is start out with sort of some definitions of modular, just so we all use the same words when we mean the same thing, or mean the same thing when we use the same words. I think that'd be helpful, and we want to sort of do that in the context of security. So, I guess the biggest, we could start with like the worst case of MEV is these sort of long-range time-banded attacks that are sort of hopefully prevented by some kind of economic security. So maybe we could start there with asking, like, what is the model, like, what does a modular blockchain do? How is it secured? What are the assumptions? And what does that have to do with the overall stability of the system?
I think the best way to think about modularity is sort of the classical computing analogy of you have many different computers, they have different resource access, so they have different compute and different sort of state that they're executing, and they have some method for communication. That method for communication might be some type of message passing system. It may end up being some type of deferred computation system, but effectively they have a way of communicating yet operating somewhat independently while synchronizing. Anything I missed? Because you wrote the definition for domain in that paper. So
Yeah, no, I think that sounds good. I saw there was a talk earlier by Mustafa, and I think you were defining what a modular blockchain is in your context. So I don't know, there's like multiple definitions floating around, and I'm not entirely sure which one we should
Let's use the simplest one.
Well, I mean, the simplest one is what Tarun mentioned. I think it's the kind of like the architectural one.
Yeah.
But then in practice, I think you have different applications, I mean, different approaches to where you want modularity on your chain. And so there's like some approaches that have been stated, I think, earlier today. Then there are other approaches as well. I think what Tarun is referring to some extent, is the modularity even in like parallel computing, right? Where you have like multiple threads. To some extent, there's like modularity there and how you manage communication between these threads.
Sure. I think like if we had slides and we don't, there'd be like some kind of diagram and there'd be actually the last presentation from the guy from ZK Snarks had this photo, where you have like, and there's a transaction and someone executes it, and then someone agrees on the order, and they're not in the modular architecture, they're not necessarily the same people, right? Which of course you could start to envision how there'd be sort of a different, as soon as there's communication, as soon as there's asynchronous, as soon as there's layers into things, that's kind of where MEV lives, sort of at the intersection of varying security models, or at these layers, you could say. So talking about security now, we have an idea, like if we were on Bitcoin, and hopefully no one's using that anymore, you'd have some notion of like how expensive it would be to rewrite the network, right? And it would get more expensive. do those security assumptions hold true in the modular? Does the modular architecture, first of all, say anything about that? Is it indifferent to sort of proof of work, proof of stake, or whatever, or does it really imply certain new security assumptions?
I guess each unit has its own local security assumptions, but then there's sort of some synchronization guarantees that are, held between the different units. So, and maybe it's because I'm older in this space, but I think of everything in terms of like old school parallel compute. Mm-hmm. And when you write kind of like multi-threaded code or you write multi-processing code, you oftentimes will have this sort of notion of like independent units that have some amount of minimum shared state, and they're only allowed to kind of communicate through that channel. And one of them could flood that channel and then halt execution somewhere else because it kind of DDoSed the other chain or other process. You kind of have the same issues here, where effectively you need to ensure that the communication channel is sort of resistant to some extent to being DDoSed, that it's expressive enough that it can actually send all the messages that are needed to be concisely communicating between the two chains or two processes. So you basically have three sort of, in any pair of communication, you have three security kind of models. You have one for each of the two sides, the two processes, and then you have one for sort of the synchronization mechanism. One of the biggest, if you look at something like the wormhole attack, these kind of like mint bugs come from the fact that like the two sides may not agree on the security model for the communication layer, and that's usually what's exploited.
But you could say that in some ways the offering of a project like Celestia or one instance of this modular architecture is to kind of share security, so that there are sort of like some component that does the data availability, and then state machines and executions are kind of separate from that. And there's this idea that maybe if security is cheaper, right, you could do more things. You could push innovation to other layers. So in this modular stack, you could have one layer that is maybe super secure and but not very useful in general sense, and then other stuff that is like much more useful and doesn't have to worry about security. But from an MEV perspective, you could imagine that at some point someone has to decide on the order. And that's the bit that I would imagine you would want to be, let's say, the most secure.
Yeah, so if we actually think a little bit back to Linux's development, it took almost 10 years for Linux to actually have reasonable SMP, which is like its multi-core, multi-processing unit, so that when you write some piece of code, the Linux scheduler could decide how to sort of like shard the memory that for each process and allocate the processes to each CPU, manage the page tables, all of that stuff. And the reason it took 10 years, it's actually really hard to get this communication part right. Like, and this is without people having economic incentive to DDoS your CPU. It's actually that the scheduling algorithm is actually really hard to write because you need some notion of shared state and common state to all these processes, which is where I think something like Celestia becomes useful, is actually having that initial kind of agreement on sort of data before you start trying to do these kind of like mutexes, lockless queues, things like that.
This is completely off topic, but interesting to me, so I'm going to say it. Like in FreeBSD, are you familiar with what happened in FreeBSD? And so there used to be this FreeBSD, and then it became Dragonfly BSD because they had different models, or different models of parallelization that was sort of sufficiently different to sort of warrant the project sort of forking. Do you think that this is something, or these kind of disagreements, like is the intellectual space of modular blockchain sophisticated enough that there are sort of like multiple models, and how do you think those models will sort of maybe evolve in parallel, compete, or eventually integrate?
Yeah, I mean, I think one important piece of interoperability between all Unix-like systems and POSIX-like systems is that their file systems are very similar, right? Like they all you can basically install any formatting on any of those devices versus like the Windows version where like you effectively had to do all this emulation and it took forever for Linux to actually be able to read Windows formatted devices. But I think the second thing is that the memory models, while different, have some notion of translation, and you can get some sort of bitwise identical behavior on both sides. And that's the key thing, right? You want bitwise identical execution and bitwise identical sort of storage and agreement on that. And as long as you have that as a standard, then you can get a lot further than, say, you know, like what ended up happening in Windows, where like parallel compute never was able to take off. And to some extent, I would argue that Windows missed. I mean, there's many reasons Microsoft missed the cloud computing world, but one of them is this: is that it was extremely hard to actually interoperate with these.
And sort of, Alex, like from your understanding and research on, I guess, on the Ethereum space, right, which is, let's say, more diverse. It's a pretty big ecosystem. Many examples of this modular, like, split. There's many L2s in Ethereum. They're already sort of competing, I would say, in a way. What's your sense, and like which one is best for MEV? And why?
Which one is best for MEV?
Yeah, which one?
Which party? I mean, it depends on who.
For Bain Capital. For Bain Capital. Like,
no, but I was going to bring it back to what Tarun was talking about. Yeah. If we bring it back to like the space today, sure. I think Tarun is kind of talking about standards to some extent as well for communication, for interoperability to some extent. I think we kind of need that for security. I think if you have completely different security models, I think it's much easier to, so take like, let's take two different worlds. One where you have like one big blockchain, right? Where you have like a homogeneous security model, where you have like, you know, security model can be understood holistically, and then say you have like a patchwork of chains that have different security models, different like, however you want to define your security model, etc. Intuitively, it feels like the patchwork of chains is easier to attack, because you can attack like smaller units of it, grow in strength, and then be able to attack more. Whereas the first one, I think, is harder to attack maybe up front, but if you find a flaw, you can like the whole system can fall. And I think currently we have these like patchworks of different chains and different models. Even in the modularity approaches, there's like different modularity approaches, but also in where the security assumptions lie. Same thing for like the bridges, whatever. This is all over the place right now. And I think it makes it much easier to attack. To a sophisticated attacker that wants to like attack the overall system. So what I think, and also for usefulness of the system, if there's some standard that's agreed upon that people can coordinate against, it can be a very simple tool, but something that people can coordinate with cross-domain.
But there are sort of like concrete examples. Like I know that Polkadot has XCMP, Cosmos has IBC.
Right.
There's a few.
I agree. But I think maybe we need that that's more universal or more general. I think IBC is hard to integrate in some chains, as far as I know.
As hard as integrating a light client, yeah. Light clients are, you know, non-trivial.
So maybe that's the thing related to MEV, right? The more you modularize, the more your stack is complex, the more there's like new attack vectors that emerge, and the more there's complexity in being able to reason about the economic security of that stack. I think that's important. In the case of modularity, where you use something like Celestia as your data availability layer, there's also the security budget you need is kind of dynamic, right? So the more like domains you add on top that use Celestia for data availability, maybe you have to think about how that affects the security of that layer. So I think it's also dynamic in that sense. And to me, trying to reason through this, the more simple that is and how we reason about the security of these different domains and how we compose the security together, the more I think we can build like a strong, resilient system.
But what are the sort of like, to switch topics now onto sort of incentives, like as like an L2 creator or a roll-up, like like if you were just launching, I don't know, SushiSwap clone as a roll-up, like beyond the incentives of like the settlement layer being sort of secure, you wrote a little bit about how there is this competition from fees to move between the base layer and the sort of roll-up or the application or higher up the stack. So how, maybe you could elaborate a little bit, like how do you see like value accrual sort of evolving with, you know, potentially deeper stacks, you know, L3s and so on, and what impact do you think that will have on sort of stability, like not just having something secure at one point, but sort of long-term security, predictable security?
So maybe two answers, and I'll pass it to Tarun as well. one, in terms of like value accrual, from a perspective of designing the system, you want value to be where you need like security, right? So like value related to security budget. So I think there's like some relation there of like where value could accrue. And then the second thing is like owning order flow and owning where the customers are. I think to some extent there's like value there because you own the touch point that creates economic activity. So these are like two ways to look at it. So to some extent, the order flow part is like whoever runs the UI that users interface with, because then they can redirect your transaction to some other stack very easily. But at the same time, a stack that isn't secure won't be used for long, and so you need that stack to be secured properly. Whatever that means in terms of value that has to back it, how much has to be staked on it, how much does it cost to attack it relative to the economic value that's on top of it. Is there an incentive to attack it because you make more money by the value that you secure on top of it, etc.
But there's also cases when the protocols are incentivized to sort of like be attacked, like in the sense, like if you're a DEX or whatever, and you're trying to bootstrap, you're trying to get liquidity, like, you want to pay the liquidity provider as much as possible. If someone is sandwiching or adding more value, like people are sandwiching, attacking, consuming the spread, technically that money is going from users to LPs, right? So there is this incentive play where it isn't always clear, and it probably changes over time. Like, hey,
There he is.
hey.
You need to have a little more of a rocky run.
Oh, well, I was expecting music while I was coming in, but clearly that didn't work out. What happened?
Yeah,
Right,
welcome.
sorry.
No, very nice to meet you.
Sorry, yeah, I guess I'm just a paid actor, actually, so I'm not really, I'm in stand-in, really, so it's great. Anyway, sorry.
No, but we were talking about incentives, but I think I interrupted Tarun if you wanted to speak sort of about the incentive question.
Yeah, I mean, one very high-level view of like sort of the game theory difference between single-chain MEV and multi-chain MEV, and obviously this is a stylized, simplified version of this, is that in a single-chain MEV is really a congestion game. There's just like a fixed number of opportunities. There's a bunch of people who are all competing to basically capitalize on those opportunities, and auctions can be designed to be like a reasonable way of dealing with congestion in like most economic situations. However, in the multi-chain world, it actually really becomes like a routing problem, right? Of like, how do I go between these different chains and maximize my value? And the routing problem is actually a much larger sort of state space of like possible ways that things can go wrong, which means you need to coordinate the incentives along the whole chain. So like, let's suppose I have a sandwich attack that's a sequence of sandwich attacks across bridges that on each side use an AMM. Well, then I actually need to make sure all the LP, to your point earlier, I need to make sure that all the LPs kind of end up having like similar incentives. But there's not really a great way of guaranteeing that in a sort of multi-chain world, right? You actually would have to synchronize those constantly across all of these.
Or just take the risk. Like, it could be atomic, and then you say, oh, I assume that I'm using flashbots and that I zero risk. But if you're like, again, Bain Capital or someone with serious money or like a market maker, oh, sorry, you're here, I forgot. You'll just execute the trade. Your short-term prediction model will say whatever is going to happen, and you'll do it, and you're going to be right, enough times to be Bain Capital.
So here's a fun little alpha leak, actually. Here you have a model of that's probabilistic.
Yeah.
Turns out that problem is convex too, so actually you can solve it. But anyway, sorry, I didn't mean to detract. Maybe that's too much of an alpha leak.
But I guess the point is like you have to coordinate these incentives a lot more, right? And right now we don't have, the fact that like flashbots can be isolated from the incentives that people are using to bootstrap pools is not really possible when you think about it in terms of modularity.
So is that to somehow suggest that smaller players are going to have a harder time in this fragmented liquidity world?
Absolutely. Yeah. You need more capital to be able to do this, right?
Yeah, it's kind of rough because I was talking with Zaki about this, and it was like, oh, when you have like 1 million FMO-based chains or whatever, maybe not 1 million, like let's say 1,000. And we were trying to ask this question, like, oh, will it actually be possible to do this kind of things? And it was like, do you think like Jump Capital would have any problem putting $1 million in 1,000 plays? I don't think so.
No.
I think that most market makers are big enough to like make the spread, to take the inventory risk, and sit there and get like the juiciest part when it arrives. So if someone is writing this complicated model, and like even if they are, like say everything is connected over IBC, and you actually can, there is sort of some kind of secure transmission between these things. Like it's not like an exchange where they can like stop withdrawals or something. It's like an automated, permissionless interop thing. Even if the people who are trying to move liquidity around are always going to have a harder time than someone who just keeps liquidity everywhere.
I mean, I guess this gets to Alex's point about like who owns the order flow owns a lot more than than you think. And the question is, in this multi-chain world, will the order flow actually be owned by an aggregator, or will it be multiple kind of like separate front ends that end up fragmenting the order flow? And then right now it looks like the latter, right? No one's actually built a very good cross-chain aggregator. And part of the reason is that the front ends don't want to take the inventory risk, right? Like the market makers do, but the market makers also don't make products. So they're not like getting user flow.
But it could be just because it's just not worth it yet. Like it could, the markets might be too, or
I don't know. There's some bridges that are backed by market makers, right?
Yeah.
Wormhole being, notable.
For sure.
Right?
But,
I mean, we get a sense of the size of their ambition that by the fact that there was a hack and the next day they, paid 350 million back to the bridge.
but they also raised that again right
Sure.
after.
No,
Let's not forget that it did get covered in a future fundraise like
but
3
I
weeks
think
later.
the order flow cross-chain is at the bridge level, in my opinion.
I think when Jump started Wormhole, there was kind of this sense amongst people that like this was their version of like the microwave tower, and like you want to win the New York Chicago microwave tower. There's a really horrible movie that if you want to watch on the history of this called The Hummingbird Project. Worst acting I've ever seen, because it's a movie about like HFT, so it's like can't be good acting. But like honestly,
Jesse Eisenberg is in that.
Yeah.
yes, exactly, and still a horrible movie. But
I liked it. I don't know.
But it is factually accurate that like the bridges, the effective war we see with the bridges now, in the normal world converge to one thing. But here it actually seems like it's not going to be true, right? Like it really does feel like there's going to be quality of service versus bridge security trade-offs, and you're going to have like the spectrum of that, and then people are going to allocate to that. And that'll have a totally different microstructure than normal markets.
Yes, I think that makes a lot of sense. But even in a permissionless system, like some people use bridges, but not everyone needs to. And I guess the question is, when is it eventually going to, or will it happen that the bridges will sort of, like if you wanted atomicity across a bridge, you just have to be two. Like if you're validating, like who's to say that you can't operate on multiple networks simultaneously? But as like an infrastructure provider, I guess like I'll talk from the Cosmos case because that's what I'm most familiar with. A lot of validators operate on multiple networks. There's no reason if the blocks are like the leader election, the person who proposes the block is predictable. If you could predict the time on both networks, right, then you could actually do a risk-free cross-chain thing and go around the whole bridge dilemma. So how do we think about the incentives for not just Jump, but even hopefully smaller validators, smaller operations to start doing multi-chain operations that sort of benefit from multiple or simultaneous order flow?
One thing there, that's part of the paper, the cross-domain MEV paper, right? So we talk about that to happen, but then we talk about the fact that if, say you're a leader on chain A, I mean, I'm a leader on chain A, you're a leader on chain B, and we want to collude or collaborate, however you want to frame it, in order to get that like economic atomicity across ourselves. We don't trust each other, so we need a way to trust each other. We also need a way to communicate, right? I think you can model all of that as some like additional economic cost that a player that is the leader on A and B at the same time doesn't have. So I think you can maybe point to an incentive for someone to control both of these like validator sets, for example. And that's what's problematic, because maybe the pursuit for alpha is such that the system equilibrium doesn't go towards many smaller validator sets that actually have a way to collude with one another trustlessly at minimal overhead, but rather a very large player that starts owning more and more of the validator sets on many sites so that they get these leader election slots and they can reduce the overhead of communication. There's still some communication, but it's internal communication, and you don't have that trust cost as well because you can trust your internal systems to work to some extent. And so you can lower the cost to do some interactions. And you can maybe even seize pockets of opportunities that, for us who don't trust each other, the cost of coordinating for that opportunity would be too high.
Well, you can put an auction between it, right? I think that's what you're sort of alluding to.
Yeah, I just think like the lack of atomicity actually changes the outcomes of these auctions, right? So you sort of have to like have an auction where you coordinate like let's just even in the simplest case of like I have 2 first price auctions of like on both sides, and I go across the bridge. I actually have to coordinate that the reserve price and the floor price and stuff like that, the initial setup is the same across both places. And there is a cost to that. Like if eventually you still have to pay some amount of money to synchronize those things. But that might go to 0 over time though.
Ideally it does. I think ideally we want it to. Or at least not 0, but as close as possible.
I think ZK stuff will be the only way to get to the point that cost gets arbitrarily small in the long run.
Because what? Because it lowers the communication complexity?
Yeah, exactly.
But you would still have like a back and forth to some extent, right?
You know, the question is like, I only have to send you one packet, and you can verify that like it's correct at the same time. That it's like I did the computation correctly on the other side, so I don't have to like do any interaction. So in that sense, it's good.
Question for you both.
All right.
Right. What if, say, we go back to that same example, right? And we send each other the packets, but now we need to split the profits. How do we split the profits?
I mean, that you can have as a contract on both sides, right? The profit, you store the final profit on one side, right?
Right, it's always on one side. It can't be on both
You have
sides.
a contract that's doing that.
You could also do like, I mean, the question, I don't know if the question you're getting at is like, how much profit do you split?
Yes,
This is like the cake cutting
how
problem,
do you set the optimal
That's the
profit
point.
split?
Yeah. So this is actually a well-studied problem
Okay.
in game theory, which is called the cake cutting problem, the pie cutting problem. Depends on who you ask and what your aesthetics are. So you could actually, there is like a weird set of equilibria that you can talk about here. And often they're actually quite stable too. So it is surprising depending on who the first person is who's like taking some of the risk.
Okay.
But
and how do we think about like adversarial things where like say we're splitting and like we agree on 50-50, but maybe there's someone else who's willing to do 60-40 or maybe over time, if you, like in an iterated game, instead of this particular opportunity, it starts making more sense for me to own more of the network rather than split with him, right? Because then it's like 100-0 instead of 50-50.
I mean, this is why proof-of-stake networks that have, that draw the entire validator set over an epoch before the epoch where you know the blocks, like, are just, you can't avoid this problem.
Right.
Because you already see this in Solana and Avalanche, right? Where like people are basically just paying validators ahead of their block number and co-locating like
for liquidation.
It's just
and that type of stuff.
yeah. I mean, even DEX are people are just basically paying.
Do we need to
validators ahead of
avoid
time.
like any kind of leader election that's in the future? Do we need like proof of work like leader election?
Yeah,
like
and that's
does?
a ZK thing,
Yeah.
right?
Okay.
The single secret leader election kind of type of stuff is only enabled by like homomorphic encryption and ZK stuff. So I think this cost goes down if cryptography gets better. It's not a purely economic
Can't
thing.
you use the like Algorand leader election model that's like VRF based or something
With
like
the
that?
committee? I mean, there's still these like poison committee attacks that are known. So.
you can also still often grind too. So
Sorry to cut you guys off. Do you guys want to take one question from the crowd before we get off?
Oh, shit.
Super interesting conversation. I just want to open it up a little bit to if anyone's been waiting, has a question. I don't know how this works. Do I just point to the person and then the mic goes? Or-
Yep.
Yeah.
Yeah, guys, we have lunch one, so this will probably be one of the last questions. Where was the person?
There.
There you go.
This is a question for Alex about Flashbot's architecture and how you see it changing in context of multi-layers and modular blockchains. So like Flashbots right now and the way it's designed is very practically helping democratize MEV on Ethereum with like enabling many searchers to participate and miners. But in context of like what you guys were talking about with like, you know, people with the most capital being able to get MEV on like cross-chain worlds and multi-layers and modular blockchains, how is Flashbots intending to like change its architecture to help further democratize MEV. And yeah, in context of like, obviously you guys are also trying to like become censorship resistant and decentralized. So you seem to have a lot of like competing priorities, but I think this is like a big one coming up. So curious to know.
Yeah, great question. We think a lot about the risk that I mentioned earlier, this like centralization of validator sets across many domains and how this kind of world can be attacked. We also see it as like it's inevitable that the world, at least for the next few years, is going to be like multi-chain or whatever. Even if you focus only on Ethereum, you have many layer 2s that have raised like hundreds of millions, are going to be able to subsidize activity for a while, even if it's artificial. And so we need to prepare for that asynchronous world and what that means there. I don't know if looking at it as simply as like, oh, players need more capital to participate makes sense, because even today on Ethereum, you know, there are flash loans, but if you use flash vaults today, flash loans are not gas efficient compared to having the capital directly, so a lot of players need the capital to be able to execute a lot of opportunities. But does that change massively in the cross-domain world? I think what changes is maybe like the inventory management logic that you need to have, and also the maybe economies of scale, that if you have more capital, you can warehouse risk a lot better. And so you can maybe take more opportunities or take more risks. So we think a lot about that. We think a lot about like this dystopian future of like very centralized blockchain world in general, where you have like a few validators that run validators on like 100 different chains and, you know, run bridges where they provide liquidity to users. That's like the worst thing for us. And we need to adapt, right, for what I just mentioned now. We're going to announce more on this relatively soon. So you'll have like extra details there. But we're worried about the same thing that we were worried about when we started Flashbots a year and a half ago, which is we want to keep the system decentralized. We want to keep it transparent as much as possible, because the more you have opacity, the more it's difficult to understand what happens within it. Yeah, what else do we want to keep it? We want to keep it like accessible to most individuals. Yeah.
I guess I'll add one point on the fairness aspect, which is that even though these bridges that have synthetic assets tend to be the ones that get exploited first, synthetic assets and like staking derivatives, especially in proof-of-stake networks, do actually lower the cost of capital for the actual validator, because validators basically, smaller validators can lever up around opportunities that they want to kind of subsidize. And so one real question is going to be, how do we balance this centralization effect versus like, should we allow like more kind of derivative assets across bridges? And that's obviously going to be this big security question, because, you know, Wormhole is the greatest example of like what happens when the staking derivative blows up. But, you know, it is clear that that actually does lower validator centralization. So yeah, in the long run, there's going to always be this kind of trade-off between like how much we want derivatives for equalizing access versus.
Why does it lower the cost?
Yeah, so like let's say I'm a small validator and I have like 1% of stake. I can borrow against my stake and basically, at least for a short amount of time, get to say like 3x leverage on my existing stake. And now I can go restake that, get 3%, increase my number of blocks, and try to basically.
But surely if you own 50%, you can borrow 3x leverage as well, right?
No, you're actually, how do you borrow 3 times 50?
Oh, you said there's no liquidity for it.
There's no liquidity for it. So there's this kind of liquidity versus security trade-off that naturally comes up in staking derivatives. So it's always going to end up being this war between like, how much do we want these kind of very hard to price derivatives that can blow up versus how much do we actually want centralization?
Cool. I think that's a great place to end it. Thank you very much, panel.
Cool.